Okay, what I'm going to do is show you how we get the formula for volume of revolution. First of all, taking it back to finding an area by integration. So we've got a curve and we want to find the area between the curve and the x-axis. And to do this, we split the area into rectangular strips. So if I take a strip across here, like so, and I label that position there xy, then we have a small increase in x here, which is called delta x. And you let delta x approach 0, so you have infinitely many strips, and then that ends up giving you the area of the region. The formula to find an area when you're integrating is the integral between b and a of y dx. And if you think about what this y dx represents, it represents the area of one of these rectangular strips. So I'm multiplying y by delta x, and then the area of the rectangle is approximately equal to the area of the strip up to the curve. With a volume of revolution, what happens is the strips get rotated, we'll start with the x-axis, around the x-axis by 360 degrees. So if you imagine that I've rotated the strip around the x-axis by 360 degrees, then it's going to do something like this. So this is a rectangular strip being rotated around, and that will give you a cylinder. Again, if this is xy, width across here, delta x, then the volume of that cylinder, or cylindrical strip, V, is equal to pi y squared, so that's the area of that circle, times the height, which is delta x. So it follows from there that if you have an area and you want to rotate it about the x-axis, so I'm spinning this whole area around the x-axis to create a volume. Hopefully you can visualize that. Okay, it's going to look something like that. Then that volume is equal to the integral between b and a of pi y squared dx. So that's the formula for volume of revolution. It's not in the formula book, you need to know that one. You also need to be able to rotate about the y-axis. So we have a curve that's coming up this way, limits on the y-axis. So we could rotate that about the y-axis to create a volume. Then that volume is equal to the integral between b and a of pi x squared dy. And I'll show you how to use those results in the next video.